Assalamu alaikum warahmatullah. Hello guys. Today we will talk about history of deep learning and this is part 1. Let's get started. Screen and webcam. Okay, let's go. So I make some notes and we will go from each note one by one and I will give some comments. So this is very good if you listen this and watch this in quiet place, and I highly recommend to pause my video and read again or listen again, because they are they are fundamentals of current status of deep learning and AI. I know now there are a lot of gold rush, there are a lot of kind of hypes around AI, around deep learning, but I want you to focus on this background and history. Let's get started. So, inventors have lo- inventors have long dreamed of creating machines that think. So we are now in 21st century. There are 21st century ago there were people living, and before that there were people living, and inventors, scientists think a lot about creating machines. So that's like it has very long history. And when programmable computers were first created, people thought that, will these machines have intelligence? And the like even they were built in like 1842, like 2 centuries ago. So 2 centuries ago, people were thinking like, will these machines have intelligence and what will be the future looks like? And now if you look from past to the future, now we have like ChatGPT, LLMs, robots, and going on like intelligence kind of. So, and in the first stage of AI, the field rapidly tackled and solved the problems that are intellectually difficult for human being, but relatively straightforward for computers. What's that kind of problems? That are problems which are based on mathematical rules, based on the concrete, absolute, deterministic rules. What they might be. It is like solving some functions, formulas, based on the mathematical calculations that are always correct. And as you know, for computers, it is easy to calculate that kind of calculations that are deterministic, that are like based on the formulas. That's easy for computers. But there is another thing. There was a big challenge for AI to solve tasks which are easy for human to do, but they are not easy to describe as formulas. What they are. So one example is that recognizing spoken words. How people recognize when they say one word, another word. How people can recognize their friends on the photos. How people see, recognize, detect, and they are we are doing like intuitively. Like we don't use brain actually. We just look and it's like it's done. Like we can do that, and we do it intuitively. That it is a bit difficult to tell computer to do that, because computer doesn't have brain, and that was a challenge. Like it was in the first stage. Like computer can calculate mathematical things, but it cannot do what we can do as human, and that's easy for us to do, like straightforward. And so let's go to the next one, is that why we call this field as deep learning. Deep learning models consist of multiple layers. There are layers, we call it nodes, and each layer learns to transform input data into some kind of abstraction and to give output of certain value. And usually this kind of layers of nodes are a bunch of them, like maybe 100,000. And like first, uh, if you look from the if you look to this from paradigm of the layers, these layers are a bunch of layers, and we can give hundreds, thousands of this kind of layers, and that makes it like deep learning, like this field called as deep learning. And so that's why we call deep learning. But there are, if we look from another point, there are another reasons why we call this field as deep learning. But that's not our topic for today. Next, ability of AI systems to able to acquire their own knowledge by extracting patterns from data is known as machine learning. So people usually misunderstood that what is AI, what is machine learning, what is deep learning, and usually AI is just very big field, and machine learning is inside of AI, and deep learning is inside of machine learning. So what is machine learning? Machine learning is ability of AI system to be able to acquire their own knowledge by extracting patterns from the data. Okay, if AI system extract pattern from the data and able to acquire their own knowledge, their own weights, that is called machine learning. The simple machine learning algorithm called naive Bayes. We use it usually for classifying the ordinary emails from spam emails. And there we give data and use probability distribution, and it use based on the data whether probability mass function or probability density function, and it returns us probability that this email belongs to spam email or not. That's very simple machine learning algorithm. It learns. And if you want to dive into this naive Bayes classifier, this kind of probability model, there is my video. Check out somewhere here and go to there and watch. I did practical session where I write it in details. So the simple machine learning algorithm is naive Bayes. But if you look today, why people don't use it? Like if you now look today, there are a bunch of complicated, complex models, and it means that there are some disadvantages of naive Bayes of simple machine learning algorithms. What they are? So that performance of these simple machine learning algorithms depends heavily on the representation of the data they are given. So for machine learning algorithms, this is that simple one, that they depend on what kind of data you give them. And we call that things like garbage in, garbage out. If good data, good output, good accuracy. If bad data, bad representation, it will be bad, poor accuracy. And we call that like data is new oil, data is new, like very valuable, because we can teach these machine learning algorithms to do that things, but they are depend heavily on the data quality or what kind of data we are giving. Example. A useful feature for speaker identification from sound is estimate of the size of the speaker's vocal tract. So if we want to classify or to recognize the speaker, we can use such kind of feature that it shows us like speaker vocal tract number. So it's like independent and it has bunch of numbers that we can somehow represent this. We can represent vocal tract as one feature that helps us to identify, to classify speakers. So like it is human doing that things, right? Or for example, if we want to predict next month's profit of the shop, of ordinary shop, if we look to GDP of that country, and if we look to the previous month's income or revenue of that shop, we can give like good accuracy, good prediction. And that's all my assumptions. That's not what model deciding to say that, hey, let's take GDP or let's take another variable, another feature. It's what I am assuming, like as human. So that I am saying to machine learning that these features we will select, and I am giving these features to machine learning, and I am seeing the output. So I am repeating again, the performance of these simple machine learning algorithms depends on how the representation of the data they are given. Okay, right. It means I cannot give raw data. In terms of this naive bias, if you look to my video, if you watch my video, there we have special probability for, we have like number of occurrence of one word of in that email or in that bunch of data set, and that are features are did by human, are created by human. So that's not how emails looks like actually. So it means that we get email, we transform into this probability, we transform that into the small representation, and we give this representation of data to the model. So if representation is bad, then model is bad. So that's the problem of simple machine learning algorithms. For many tasks, however, it is difficult to know what features should be extracted. Yeah, for sure, like if that feature selection is done by human is like, it means like we should do it manually, it's time consuming, it is expensive, and it's also difficult to represent video images which are like a bunch of pixels. But although it might be easy for tabular data to represent, if it's easy for text data, but it's still, it is very challenging to select right features. And after having that kind of thing, representation learning come out. So what is representation learning? So scientists decided that we need machine learnings to discover not only mapping from representation to output, but also the representation itself. So scientists say that we need such kind of models which will select features by themselves, that we shouldn't care, we shouldn't think about what features to give, that models themselves should calculate that this feature is important, that feature is important, and this is called as representation learning. In other words, representation learning is a set of methods that allows a machine to be fed with raw data, raw pixels, and to automatically discover the key features itself. Okay, see, automatically discover the key features like the GDP, another kind of unique thing that people cannot see because we are maybe limited in terms of like 3D dimension, in terms of our brain. So we want machine learning themselves to automatically discover the features, key features themselves. In traditional machine learning, models often rely on hand-engineered features that human made. This means a human being must be involved. He must decide what attributes of data are relevant for model, which are not. So, representation learning is important, so that it gives machine learning models to not only acquire the knowledge, but also decide which features are important for acquiring that knowledge. The example of representation learning is autoencoder. So stay tuned. In the future, I will create I will write from scratch in Python this autoencoder, inshallah, and please check my playlist. It might come out when you are watching, maybe in the future. So, a major source of difficulty in many real-world artificial intelligence applications is that many of the factors of variation influence every single piece of data we are able to observe. This intangible. This is term. This intangible. It means to structure the learned representations so that each feature captured by a model corresponds to a single underlying aspect of the data. Again, this intangible means to structure the learned representations so that each feature captured by a model corresponds to a single underlying aspect of the data. Example: object detection in busy street scene. Consider an object detection system based on the image for self-driving car. The system should detect and localize various objects such as pedestrians, bicycles, cars, traffic signs, animals on the road, and there are challenges, Objects might overlay. Pedestrian walking in front of parked car, making it difficult to separate and identify each object correctly. There are that kind of small challenges, and model should understand and it should classify them also. That's challenge. Another challenge is that objects of the same category may appear in different sizes based on their distance from the camera. If, for example, I am here in this distance, it's clear that I am human. But if I now stand up, camera will see only my legs, and it means it's challenge for camera. It's for challenge for AI to classify me as human. That's another thing. If I go far away, I will be very small. That I will be look like ant or small insect. That it's also difficult for AI. That's challenge. That kind of challenge we call it this intangible. Second, viewpoint variation. If, for example, object shown from different angle, it is different. If you show me from the top, you will see only my head and a little bit of my shoulders, and it's also challenge for object detection model to understand that it is human, it is me. And there are also illumination. If you take a picture of me at the dark, I will look like maybe like not clear enough. If you took my picture in the street, for example, now it's sunny in the street, it will give another kind of challenge for model to classify. So this kind of challenges always occur, and deep learning should successfully understand the challenges and classify and work. So that is challenge that deep learning models should tackle. Deep learning solves this problem in representation learning by introducing representations that are expressed in terms of other simpler representations. Deep learning enables the computer to build complex concepts out of simple concepts. And there is one example. For example, here we have example of classifier. So we have image, the 3 channels. Actually, it's not channels, it's like colors. And this one is that hidden layer. This is layers. And from here, it tries to learn that if this kind of matrix, it tries to learn maybe like there is that kind of shape, round shape. It tries to learn, for example, here you can see that human body, edges, contours. And it tries to learn, like, for example, for car, if there is that kind of edge, round, and there is that kind of rectangle, it means it belongs to car. If there is like head and 2 hands, it belongs to human. If there is kind of something like bird. It looks like bird shape. It tries to learn by itself that kind of small features to successfully represent and classify. Here it's like round, the color schema maybe, and yeah, like what kind of color it consists, edges, and the color actually, and by this it learns. This is example of representation learning. To learn more, check out this deeplearningbook.org. There it's much more detailed of explanation of introduction to deep learning. And the example of deep learning model is a feed-forward deep network, or multi-layer perceptron, MLP, not NLP, MLP. A multi-layer perceptron is just a mathematical function mapping some set of input to output values. So we have that kind of feed-forward deep network, and I will write from scratch in Python, inshallah, this network, and stay tuned, and it will be on playlist. You can watch and you can see how it looks like. And lastly, I want you to look to the machine learning and map this picture in your head, that there is knowledge basis. We can call it as AI, and in this AI that computer systems think, able to reason, able to think, and in that thing we use machine learning. In that thing there is machine learning. Again, what is machine learning? Machine learning is AI system which can learn on their own based on the extracted features from the data. And in machine learning we have representation learning. What is representation learning? Representation learning is that that the model, the system, should not only learn knowledge from given data or from given features. It should take the data and identify important features, and also try to learn knowledge. Knowledge. Okay, try to learn knowledge and important features. And in that we have MLP, multi-layer perceptron, or we call it feed-forward deep network. So that's inside of that representation learning, and that inside of representation learning we call that layer, that circle, deep learning. That's all. That's introduction to deep learning. Okay guys, that's enough for today. Good luck, see you next time.